Students, today I am going to start new unit, that is unit 4, fuels. Okay, in last class we completed, that is third unit, polymers. So next our fourth unit is fuels. It is very simple unit. So today we will do introduction and few definitions, classifications. So let us recollect what we have discussed in your lower classes, that is in 10th standard. You might have studied what is a fuel and types of fuels. So fuel is nothing but, what is a fuel? So it is a combustible substance which gives heat energy. Okay, that is called as fuel. And classifications will be there, two classification. That is first classification based on physical state and second classification based on occurrence. So two classifications are there. So these two I have studied in your lower classes. So what are the objectives? On completion of this period, you will be able to understand. So after finishing this topic, you should be able to understand these three topics. What is fuel? You should know the definition of fuel. You should know types of fuels. You should know characteristics of a good fuel and what is calorific value and its types. So these are, now we are going to discuss about these few topics and you have to understand all these topics. So our topic is fuels unit 4. So we'll do introduction. Fuels are very important in day-to-day life. So fuels are very important in our daily life. Fuels produce heat energy which is used in domestic purpose and in many industries. And fuels produce what? It produces heat energy. This heat energy is used in domestic purpose as well as an industrial purpose. Fuels are combustible material containing carbon and hydrogen. So fuels are nothing but hydrocarbons. These are all made up of just carbon and hydrogen, and these are combustible materials. Combust means it burns. The fuels which are used nowadays are deposits of plants and animals lived long back. So whatever the fuels now we are using, those are the deposits of dead plants and animals. They are lived long back. So those deposits only we are using as fuels nowadays. The fuels are called fossil fuels. So whatever the deposits of plants and animals we are using, those fuels are nothing but fossil fuels. Okay, so this is about introduction. Then come to the definition of fuel. So what is a fuel? Any combustible substance, that means which burns, gives heat energy on complete combustion in presence of oxygen is called fuels. That means if you combust any substance, it should produce heat energy on total combustion, on complete combustion. In presence of oxygen only we are burning. If you burn any substance in the presence of oxygen, it should produce heat energy. That substance is nothing but a fuel. So we'll see here equation. So fuel plus oxygen. We are burning and we are getting some products will be formed and so heat energy will be produced. This fuel is having more energy content. This products is having less energy and heat energy will be produced. So any combustible substance which produces large amount of heat in the presence of oxygen is called as fuel. Definition of fuel very important. Then next come to the classification of fuels. So here two classifications are there. So we will see two classifications. So first one based on physical state. Okay, on the basis of physical state, fuels are classified into three types. Based on physical state means whether it is solid, liquid or gas, based on that. So based on that, fuels are three types: solid fuels, liquid fuels, and gaseous fuels. The fuel which exists in solid state is called as solid fuels, and the fuels which exist in liquid state are called liquid fuels, and the fuels which exist in gaseous state are called gaseous fuels. So, and these solid, liquid, and gaseous fuels are again classified into primary fuel and secondary fuel based on their occurrence. Okay. So here I have given a table. So this is a type of fuel. This is again primary or natural fuel, artificial or secondary fuel. So which exists in solid state, that is solid fuel. This solid fuel is two types: solid primary fuel, solid secondary fuel. So primary fuel means from its occurrence, from where it exists. So in nature, wood, coal. So from these primary fuels, we are getting all these coke, bone black, carbon black, charcoal powder. Okay. Then type of fuel, liquid fuel, which exists in liquid state is called as liquid fuel. Again, these liquid fuels are classified into primary fuel and secondary fuel. So which exist in nature, that is at first crude petroleum. From this, we are preparing this petrol, kerosene, diesel, fuel oil, etc. The last one is gaseous fuel, so which exists in gaseous state. And this gaseous fuel is again of two types: primary fuel and secondary fuel. So this is from nature we are getting from the earth crust. The natural gas is the primary fuel. From this we are preparing different fuels, that is LPG, coal gas, oil gas, water gas, etc. So this is about classification of fuels on physical state. The next classification, fuels on occurrence, from where they are existing. Okay, on the basis of occurrence, fuels are classified into primary and secondary fuels. So on the basis of occurrence, fuels are classified into two types, that is primary fuels and secondary fuels. So first one is primary or natural fuel. That means primary fuels are also called as natural fuels. So what is meant by primary or natural fuels? The fuels which are available in nature are called primary fuels. So whatever the fuels which are available in nature, from nature we are getting, either earth crust, whatever it may be. Okay, so those are called as primary fuels. Example for primary fuels: wood, coal, petroleum, natural gas. These all are getting from the nature: wood, coal, petroleum, and natural gas. Okay. Sorry. Then second one is secondary fuels or artificial fuels. Secondary fuel is also called as artificial fuel. The fuels which are prepared from primary fuels. So artificial or secondary means we are preparing from the primary fuels. So that's why these are called as secondary fuels or artificial fuels. Example for secondary fuels: petrol, diesel, LPG. That means these all are getting from the primary fuels. That's why these are called as secondary fuels. We are preparing artificially. That's why these are called as artificial fuels. So how many classifications are there? Two classifications. And this classification is very, very important. First classification is based on physical state. Based on physical state, there are three types: solid, liquid, and gaseous fuels. And the solid, liquid, and gaseous fuels are again classified into primary solid fuel, secondary solid fuel, primary liquid fuel, secondary liquid fuel, primary gaseous fuel, secondary gaseous fuel. And second classification is based on its existence. These are of two types: primary fuels, secondary fuels, or you can say natural fuels and artificial fuels. So this is about classification of fuels. Then next come to the characteristics of good fuel. So if fuel is acting as a good fuel means, it should act as a good fuel means it should have some characteristics. So you'll see those characteristics. It should possess high calorific value. Okay, so whatever the heat energy that is producing, it should be very high. then it should possess moderate ignition temperature. So ignition temperature means the minimum temperature required to ignite the fuel. Ignite means to lighten the fuel. So that is called as moderate ignition temperature. That means the fuel should not burn at very low temperature or very high temperature. So at a moderate medium temperature, it should possess moderate combustion of velocity. That means fuel should not burn with more speed, less speed. It should be velocity of combustion should be medium. Combustion product should be harmless. So when you combust a fuel, some products will be released. Those will be harmless, should not harmful. So combustion product should be harmless. Then it should leave less amounts of non-combustible material. So when you burn a fuel, so all the material is not combustible. Some of the material will be non-combustible. Okay. So here it should leave very less amounts of non-combustible material, like that you have to choose. Then it should have high pyrometric effect. Pyrometric effect means the maximum temperature given by the fuel is called pyrometric effect. So it should do very high temperature so that it will burn easily. Low cost and easy maintenance. Okay, it should be easy maintenance, not sorry, easy transportation. It should be easy transportable and it should be available in less cost. Low cost means less rate. The next, combustion should be controllable and non-spontaneous. So when you combust a fuel, then you have to control that one. It should be controllable, not uncontrollable. And non-spontaneous means suddenly, spontaneous is sudden. Sudden combustion should not take place. When you want to combust, then only it should undergo combustion. So like that. So these are the some of the characteristics of a good fuel. So it should have high calorific value, it should possess moderate ignition temperature, it should possess moderate combustion of velocity, combustion product should be harmless, it should leave less amounts of non-combustible materials, it should have high pyrometric effect, it should be available in low cost and it should be easily transported, and combustion should be controllable. If you want to burn, you can burn. If you want to again off it, you should control it. And non-spontaneous means naturally it should not take place. When you want to burn, then only you have to burn that one. So naturally it should not undergo combustion. That is the meaning non-spontaneous. Sudden combustion should not take place. Some gaseous fuels suddenly they will combust. So like that it should not take place. Then come to the advantages of gaseous fuels. So you have solid fuels, liquid fuels, and gaseous fuels. So nowadays, which fuels we are using? Gaseous fuels. So why we are using gaseous fuels? By gaseous fuels, we have advantages. So what are the advantages of gaseous fuels? We will see. These have high calorific value. They produce large amount of energy, heat energy. They require low ignition temperature. At minimum temperature only we can ignite that fuel. They have uniform burning rate. The burning rate will be uniform. Okay, burns without soot. Soot will be not there. Soot means foga. Ash will not be there, and smoke. Smoke will not be. So sooty nature at some black vapors will get no black like that. Okay, burns without soot and ash and smoke. Release less amounts of pollutants. Which when fuel is burned, it should release less amounts of pollutants, because when pollutants are released, it becomes pollution. So these gaseous fuels release very less amounts of pollutants. In environmental studies, you study pollutant means the substance which causes pollution. It's called pollutant. And easy transportation. So it should be easily transported. So these are the some of the advantages of gaseous fuels. Okay, what we studied, what is a fuel, what is the classifications of fuel, that is on physical state, on occurrence, then characteristics of a good fuel, then advantages of gaseous fuel. Then what is mean by calorific value? Actually, this one included in CAG curriculum. One, what is calorific value? Just now in characteristics we studied, it should have, fuel should have high calorific value, we said. So what is meant by calorific value? The amount of heat energy given by unit volume or specific quantity of fuel on complete combustion is called calorific value. That means when you burn a fuel, when you combust a fuel on complete combustion, whatever the amount of heat energy given by that specific quantity of fuel or unit volume of fuel, that is called as calorific value. That heat energy given by the specific quantity of fuel is called as calorific value. Example, the calorific value of natural gas, that means this much heat energy will be produced per 1 kg of fuel. Per 1 kg of fuel, that is this much heat energy, kilocalories, 12,500 kilocalories heat energy is produced by this much weight of fuel. The calorific value of kerosene, less. It is 10,000 kilocalories only, okay, per kg. Per kg it will produce 10,000 kilocalories of heat energy will be produced, okay. Then types of calorific value. These calorific values are again classified into two types. Okay, first one is high calorific value, shortcut HCV, or high heating value, HHV, or gross calorific value. Three names. High calorific value, you can remember anyone, HCV enough. High calorific value or high heating value or gross calorific value. So what is meant by high calorific value? The total heat energy given by the fuel on complete combustion by allowing the water vapor to condense is called as high calorific value. So if we are burning any fuel, so after complete combustion, what happens? Some heat energy will be given. So that heat energy, and while on combusting, some water vapor will be released, and that water vapor should condense. That will be condensed. That will also comes under that energy. That is nothing but HCV. The total heat energy given by the fuel and complete combustion by allowing the water vapor to condense. Condense means it will cool and come into that one only. So that is called as HCV, that is high calorific value, or gross. Total, that vapors also condensed into that energy and this heat energy plus combined is called as high calorific value. The next you have low calorific value, LCV, or low heating value. There high heating value, here low heating value or net calorific value. Okay. The amount of heat energy given by the fuel after allowing the water vapor to escape without cooling is called LCV. So when you combust a fuel, so what is happening? Their heat energy is produced and water vapor will be formed, and that water vapor is not allowing. It is escaping. It is not cooling, just heat energy. Whatever the heat energy produced by that fuel, that is nothing but low calorific value or net calorific value. So high calorific value means vapors also comes under that one. Vapors will condense. Here what is happening? Vapors are not condensing. Vapors are not cooling. They are escaping. So only whatever the heat energy given by that fuel, that is nothing but LCV, low calorific value. So this is about types of calorific value. So how many types calorific value? Two types. HCV, LCV. HCV means high calorific value. LCV means low calorific value. HCV is also called as high heating value, and LCV is also called as low heating value. It is called as gross calorific value. This is called as net calorific value. Gross calorific value means there you are getting the heat energy plus vapors are condensing. Here only heat energy produced by the fuel. Vapors are not condensing. Vapors are escaping out. So that is called as net calorific value. Come to the summary. So in this period, what we have discussed, what is a fuel? So fuel is any combustible substance which produces large amount of heat energy in the presence of oxygen is called as a fuel. Then types of fuels, two types based on occurrence, based on physical state. Then characteristics of a good fuel, and what is calorific value, and types of calorific value. So these are we discussed in this video. Then come to the questions. So what type of questions we may expect from this unit? So very simple questions, 3 marks questions, 1 mark question, and 5 mark question is characteristics of good fuel only for 5 marks. So first of all, what is fuel? Or they last define fuel. Okay. Then classify fuels. This classification, 2 classifications are there. So whether they last physical state classification or based on occurrence classification. And once they will ask direct question, that is define primary and secondary fuels. Like that also they will ask. So classify fuels based on physical state means solid, liquid, gaseous fuels. And classify fuels based on occurrence or existence. They can ask or existence also. Existence means occurrence means same. So then you have to write primary and secondary fuels with examples. Then come to the characteristics of good fuel. Any 5 characters or any 6 characters they will ask. Then what is calorific value definition important? Types also important, but calorific value definition important. That's why I have given you this assignment. So if they will ask classified fuels on physical statements, directly write this box enough. Or if you want to write what is solid fuel, the fuel which exists in solid state is called solid fuel. Then these examples, because these again from here you have to write first. On the basis of physical state, fuels are classified into 3 types: solid, liquid, gaseous fuels. These fuels may be primary and secondary, and directly you write this table enough. This is the 3 marks question. If you want to define what is solid fuel means, the fuel which exists in solid state is called solid fuel. The fuel which exists in liquid state is called as liquid fuel. The fuel which exists in gaseous state is called gaseous fuel. Okay, so like this you have to write. So among these very important maximum repeated questions are this one: primary and secondary fuels repeated, and this characteristics of good fuel is very important. Then this calorific value in C18 curriculum. This is 1 mark question. Define calorific value. Types means again 3 marks question. Okay. So high calorific value, low calorific value, this definition is important. So for 1 mark also they can ask. 3 marks means classify calorific value types they will ask. Classify calorific value they will ask. Define HCV for 1 mark. Define LCV for 1 mark. Define calorific value for 1 mark. So what is fuel for 1 mark? So disadvantages either 3 marks or 5 marks. 5 advantages means 5 marks. 3 advantages means 3 marks. So like that they will ask. Okay. So today we discussed introduction, what is fuel, types of fuels, characteristics of good fuel, advantages of gaseous fuels, then calorific value and its types. In next class we will deal with the composition and uses of gas. Actually our next topic is problems on calculation of oxygen. Then you have this topic. So next class what I will do, and there in the next class only. So this composition and uses of gaseous fuels is very, very simple. So these problems are somewhat difficult. So problems on combustion. There is oxygen required for combustion. So in next class we will do that one. So with this we finished the first class, that is introduction, types of fuels, characteristics of good fuel, then what is calorific value, and what are the classifications of calorific value. Okay. Thank you, students.